Hi students, good morning to all. In this class, we will discuss to definition of continuity, definition of discontinuity, types of discontinuity. Okay, first go to definition of continuity. Here, let f of x be the function. Let f of x be the function. The function is defined for all. Okay, is defined to at particular point limit x approaches x naught, f of x exists. Exist means the function have some constant. Okay, these real numbers. Next, to find left approaches, limit x approaches x naught minus indicates to x approaches x naught from left side. Okay, from left side, f of x which is equal to some value, that is L. To find right approaches, limit x approaches x naught plus means the sign indicator to x approaches x naught from the right side, f of x have some value, that is L. Okay, here f of x naught minus f of x naught plus all are equal means, that is unique real number means, equal means unique real number means, therefore the given function is continuous, that is limit x approaches x naught minus f of x naught minus which is equal to limit x approaches x naught plus f of x naught plus which is equal to limit x approaches x naught f of x naught. All are equal, which is equal to unique real number. Okay, unique real number means therefore the given function is given function f of x is continuous at x equal to x naught. Okay, at x equal to x naught. Suppose does not hold any one conditions, therefore the given function is discontinuous. Identify to discontinuous. Okay, here in graph x dash y dash. For example, we take the sin x curve. Okay, sin x curve. Here the curve no breaks in any points at x naught. It means the curve no break at any point. Therefore the given curve continuous at the entire interval, therefore the given function is continuous. Okay, suppose the function has holds means, okay, has holds means at the x naught. This is at x naught, at particular point x naught means thus the curve has bearing, that means holds circle means the function is discontinuous. Okay, the function is discontinuous at x equal to x naught. Okay, at x equal to x naught. Suppose here this is another one. This is left approaches, another one x naught. This is right approaches. This is right approaches. Here left approaches have some value, right approaches have some value, but both are different means. Both are, that is f of x naught minus not equal to f of x naught plus. Here f of x naught minus not equal to f of x naught plus means the given function has discontinuous at x naught. Okay, it means this is called the jump discontinuity. Okay, jump discontinuity. Suppose the given function is not continuous means at particular point means the function is called the removable discontinuity. Okay, this is called the removable discontinuity. Okay, next we will discuss types of discontinuities and definitions. Next discuss discontinuities. What are the types of discontinuous? It means classified 3 types. First one, removable discontinuity. Second one, jump discontinuity. The third one, essential discontinuity. In this standard, we are learning only 2 discontinuity. One removable, another one is jump. We are learning higher classes essential discontinuity. Okay, now discuss to removable discontinuity. Here, removable discontinuity means f of x, let f of x be a function. F of x be the function. Be the function. Okay. Here, limit x approaches x naught minus this f of x naught minus, which is equal to limit x approaches x naught plus f of x naught plus. Left end and right end are equal, but the given function, but f of x is not defined, or these limits have different value. Okay, these values are not equal to both end. Okay, removable discontinuity means let f of x be the function to find left approaches and right approaches. Both value are same, but given function is not defined at particular point. Otherwise, or the given function to find some value, okay, to find some value, limits exists, but the value is not equal to left end and right end. This is called the removable discontinuity. Okay, in graph x, y, or z. Here x naught. Okay, here listen, this is left approaches, this is right approaches. Okay, right approaches. Here left approaches and right approaches are equal. F of x naught minus, which is equal to f of x naught plus, but at particular point x naught is not defined the given function, okay, is not defined the given function. Therefore the given function is called the removable discontinuity, okay, removable discontinuity. Suppose f of x naught minus, which is equal to f of x naught plus, both are equal, but given function at particular point have some limit, okay, have some limit, okay. Here at particular point have some limit, but not equal to both end, therefore the given function is called the removable discontinuity. Next discuss about jump discontinuity. Here let f of x be the function, f of x be the function. Here limit x approaches x naught, f of x exists to have some value, okay, some value, that is real numbers. Here limit x approaches x naught minus f of x naught minus not equal to limit x approaches x naught plus f of x naught. Here the function has defined, but both end value are not equal, therefore the given function is called the jump discontinuity, okay, jump discontinuity. For example, x, y, x naught, okay, this is left approaches, this is right approaches. Left approaches and right approaches are not equal, therefore the given function is discontinuity, is called jump discontinuity at x naught, okay. Next, examples of functions continuous at a point, okay. In the first one, constant function is continuous at every point, okay, at every point, that is each point of capital R. Capital R means real numbers, okay, real numbers, that is minus infinity to plus infinity, okay, minus infinity to plus infinity. For example, let f of x equal to, let f of x equal to 3, okay, equal to 3 as x approaches x naught, that is 2, okay, that is 2. Here to find both end rule, that is limit x approaches x naught, that is 2 plus f of x, that is constant function, which is equal to limit x approaches 2 plus function is 3, okay, function is 3. Then the result is 3. This is left limit. To find right limit, limit x approaches 2 minus f of x, which is equal to limit x approaches 2 minus the function is 3, which is equal to 3. Both end are equal and defined for the given function. Therefore the given therefore constant function is continuous at each point, of capital R, that is real numbers, okay. Next, number 2, power functions with positive integer components, exponents at every point of capital R. For example, consider let f of x which is equal to x power n. Okay, x power n. Here n is the positive integer. Okay, n is positive integer means greater than 0. Okay, greater than 0 at every point means at every point of R. For example, as x approaches 5. Okay, x approaches x naught, that is 5. To find both end value, that is limit x approaches 5 minus f of x. Here n equal to 1. Okay, n equal to 1 or any value. Okay, but n are greater than 0, that means only we take positive integer. Okay, which is equal to limit x approaches 5 minus the function is x power n. Okay, x power n. Here replace x equal to 5 into the function, that is 5 power n. Okay, 5 power n. Limit x approaches 5 plus f of x which is equal to limit x approaches 5 plus the function is x power n. Here replace x equal to 5 into the function, that is 5 power n. Here f of x equal to x power n, x power n equal to 5 power n, that is left approaches, right approaches are equal, therefore the given function is continuous. Similarly, in general, power functions with positive integer exponents at every point of capital R. It means we take any one number lies between minus infinity to plus infinity. The power has positive integer exponents means therefore the given function is continuous. Okay, next third one, polynomial functions. P of x equal to a n x power n plus a n minus 1 x power n minus 1 plus and so on plus a naught x power naught, that is the constant term, are continuous at every point of R. Okay, is continuous at every point of R. Okay, next, quotients of polynomials, namely rational functions of the form R of x, are continuous at every point. For example, let R of x be the rational functions in the expressions are p of x divided by q of x. Okay, p of x divided by q of x. For example, R of x, that is f of x, which is equal to x square plus 16 divided by x minus 3. Okay, x minus 3. Here the function is substitute as replace x approaches 3, then f of x approaches, replace 3 means 3 minus 3 is 0, denominator have 0 means f of x goes to infinity. Okay, therefore f of x is not defined, okay, is not defined. So the domain of the given function is capital R, that is real numbers except 3. Okay, except 3. Therefore the given function rational expression in the form rational expression is continuous at every point except at 3. Okay, except at 3. Next, point number 5, the circular functions sin x and cos x are continuous at every point of capital R. This is the sin x curve, sin x, this is cos x, here sin x means passes through the origin. Okay, cos x is an even function, does not pass through the origin. Does not pass through the origin. Here, the given curve, that is sin x, is continuous at every point. Okay. Similarly, this curve is called the cos x is continuous at every point. Okay. But tan x, cosecant x, secant x, cot x are continuous at proper domain. Okay, continuous function of proper domain. But sin x and cos x are the continuous at entire domain. Okay, entire point. Okay. Next, sixth point, the nth root functions. F of x equal to x power 1 by n. Square root means x power 1 by 2. Cube root means x power 1 by 3. Nth root means x power 1 divided by n. Are continuous in their proper domain. Okay, proper domain. Seventh one, the reciprocal function f of x equal to 1 divided by x is not defined at x equal to 0. It means, question number 7, example for f of x equal to 1 divided by x plus 2. Okay, 1 divided by x plus 2. Here, replace x approaches minus 2, then f of x approaches infinity. Okay, minus 2 plus 2 is 0. Anything divided by 0 is infinity. Therefore, f of x is not defined at x equal to minus 2. In other words, f of x is not continuous. In other words, f of x is not continuous at x equal to minus 2. In other words, we can say f of x is continuous. F of x is continuous except, that is continuous of capital R. Okay, that means real numbers except minus 2. Okay, all are the same meaning. Similarly to the same procedure, point number 6, the reciprocal function f of x equal to 1 divided by x. Here replace x equal to 0. The function f of x tends to infinity. Therefore, the given function is not defined. In other words, f of x is not continuous at x equal to 0. We can say in another one format, f of x is continuous of capital R except 0. Okay, next, 8th point, f of x equal to x plus 1 in conditions x less than or equal to 0. Other words, x square plus 1, x greater than 0. Here the given function is continuous or discontinuous at x equal to 0. Okay, here at x equal to verify the given function is continuous or discontinuous at x equal to 0. Here to find left hand limit and right hand limit are equal means the given function is defined. Okay, defined. To find the left hand limit and the right hand limit, both values are equal means given function is continuous at x equal to 0. Okay, now check it. Eighth one, proof f of x, given f of x equal to x plus 1. In another one, x square plus 1. Okay, x square plus 1. Here x less than or equal to 0, x greater than 0. Okay, x greater than 0. Here limit x approaches at point 0 f of x. Choose the function x approaches 0 means in particular stage x reach to 0. That is x equal to 0 means we take the function x plus 1. Limit x approaches 0. Function x plus 1. Here replace x equal to 0 into the function. 0 plus 1 is 1. This is therefore the given function is defined. The limit exists. Next, to find left hand limit, that is limit x approaches 0 minus f of x. Choose a function. 0 minus means x approaches 0 from left side. From left side means this is the suitable function. Okay, limit x approaches 0 minus, choose a function x plus 1. Replace x equal to 0 into the function. 0 plus 1 is 1. Next, to find right end limit x approaches 0 plus, choose a function x greater than 0 means positive values. This is right one, this is left one. Okay, this is left one. Choose a function x square plus 1. Here f of x equal to limit x approaches 0 plus, choose a function x square plus 1. X square plus 1. Replace x equal to 0 into the function. 0 plus 1 is 1. Here all are the same value, that is unique real number. Therefore given function is continuous. Therefore f of x is continuous at particular point x equal to 0. Okay, x equal to 0. Next, ninth one, the greatest integer function f of x equal to greatest integer function x is not continuous at x equal to 0. Okay, here example, let ninth one let f of x equal to greatest integer function x. Okay, to find left end limit. Okay, left end limit, that is limit x approaches 0 minus f of x. Okay, minus f of x. Here the sign minus represent as x approaches 0 from the left hand side. The function greatest integer function, minus means we take previous value. Okay, we take previous value, that is the function is x minus 1. Okay, x minus 1. Limit x approaches 0 minus the function is x minus 1. Left limit means previous value, replace x equal to 0. Finally we get minus 1. Okay, to find right end limit, that is limit x approaches 0 plus f of x, which is equal to limit x approaches 0 plus f of x equal to greatest integer function means right. To find right end limit means we take same function. Okay, same function, that is x. Replace x equal to 0. Finally we get 0. Left end and right end are not equal. Okay, limit x approaches 0 minus f of x naught minus. Okay, x naught minus, that is minus not equal to limit x approaches 0 plus f of x naught plus. Okay, therefore the given function is, that is greatest integer function is not continuous at x equal to 0. Therefore f of x is not continuous at x equal to 0. Okay, next one, the modulus function f of x equal to modulus of x, which is equal to minus x means if x less than 0, equal to 0 means if x equal to 0. Suppose plus x means if x greater than 0. Okay, to find a left end limit, right end limit and given function exists. For example, here f of x equal to modulus of x. Remove modulus, the factor like as negative sign if x less than 0. 0 means if x equal to 0. Plus x means if x greater than 0. Okay, to find the limit, that is limit x approaches 0 f of x which is equal to approaches 0 means equal to 0 means 0. Suppose limit x approaches 0 minus means f of x equal to choose a function minus x, that is limit x approaches 0 minus function is minus x, replace x equal to 0, that is 0. Limit x approaches 0 plus f of x which is equal to limit x approaches 0 plus choose a function positive x, replace x equal to 0 into the function, finally we get 0. All are the same value, that is unique real number. Therefore the given function, that is modulus function, is continuous at every point. Okay, continuous at all points. Okay, at all points. Okay, next 11th one, f of x is e power x is continuous at every point. Okay, suppose logarithmic function is only defined for positive values, therefore the logarithmic function is continuous for open interval of 0 comma infinity, that is continuous for right hand side. Okay, right hand side, that is positive values only, 0 to infinity. Okay, thank you. Next exercise 9.5. In the first question, prove that f of x equal to 2x square plus 3x minus 5 is continuous at all points in capital R, that is real numbers. Listen, given function solution, given 2x square plus 3x minus 5 is a quadratic polynomial equation. Isn't it quadratic polynomial in terms of x? Given f of x which is equal to 2x square plus 3x minus 5 is a polynomial equation, polynomial function, polynomial function. Already we know that some result, standard result, it is an algebraic function. Every algebraic function is continuous at every point, Therefore, every algebraic function is continuous at every point of capital R, because this is the given function. Suppose limit x approaches x naught, this is the given function f of x, that is polynomial means p of x. Okay, p of x, replace x equal to 0 into the function, that is 2x naught square plus 3x naught minus 5, which is equal to some constant. Okay, which is equal to some constant, that is f of x naught. Okay, therefore the given function is defined. Okay, therefore the given function is defined and limit exists. Okay, limit exists. Therefore every algebraic function is continuous at every point of capital R, hence true. Second question, examine the continuity of the function in the first subdivision x plus sin x. Here given function, let f of x equal to x plus sin x. Okay, x plus sin x. Here we know that the curve of sin x, x, y, x dash, y dash origin. Sin x is an odd function. Okay, odd function. Therefore, the curve passes through the origin. Here, the given curve, that is sin x, is continuous at every point of capital R, that is real numbers, minus infinity to plus infinity. Okay, minus infinity to plus infinity. Therefore, the curve sin x curve is continuous at every point. Plus x means put x equal to 0, 1, 2, 3, 4 and so on up to plus or minus lies between minus infinity to plus infinity. We take some value. Therefore, the given function is continuous. Therefore, f of x is continuous at every point of capital R. Okay, hence proved. The second one, the third subdivision, e power x into tan x. We know that the curve tan x dash y dash. This is ours by 2 minus pi by 2. Vertical asymptotus at pi by 2 minus pi by 2 plus 3 by 2, 5 by 2, 7 by 2. Similarly to the same process, the given curve is continuous minus pi by 2 to plus pi by 2. Okay, in general, that the curve tan x is, therefore here let assume that f of x which is equal to e power x into tan x, The curve tan x is not continuous at the entire interval. So the curve tan x is continuous of capital R except 2n plus 1 into pi by 2. Okay, into pi by 2. Therefore, given curve f of x equal to e power x into tan x is continuous of capital R except 2n plus 1 into pi by 2. Okay. Next, question number 2. Examine the continuity of the following function. Subdivision 5. X in x. It means logarithmic x. Solution. Let f of x which is equal to x into in x means log x. Okay, in x means log x. We know that the domain of the log x is 0 to infinity. Okay, 0 to infinity, that is open bracket. Therefore, given function is continuous at open interval of 0, plus infinity. Okay, 0, plus infinity. Seventh subdivision, let f of x equal to x square minus 16 divided by x plus 4. Okay, x plus 4. Here replace x equal to minus 4 into the given function. Minus 4 means 16 minus 16 is 0. Denominator also like as 0. 0 by 0 is indeterminate form. So simplify to the given function, that is x square minus 16 can be written as 4 square. In the structure a square minus b square, which can be written as a plus b into a minus b. Okay, a minus b divided by x plus 4. Okay, divided by x plus 4. Here x plus 4 are cancelled. Finally, we get f of x equal to x minus 4. This is an algebraic function. It is algebraic function. Therefore, every algebraic function is continuous. Every algebraic function is continuous of capital R. Okay, of capital R. Suppose the given function is not defined in another one points, f of x is not defined at x equal to minus 4. In other words, f of x is continuous discontinuous at x equal to minus 4. We can say another one form it, given function f of x is continuous of capital R, that is real numbers, except minus 4. Okay, except minus 4. Ninth subdivision, absolute value of x minus 2 divided by model absolute value of x plus 1. Let f of x equal to f of x, which is equal to x modulus of x, sorry, absolute value of x minus 2 divided by absolute value of x plus 1. Okay, x plus 1. Here replace as x approaches minus 1, then f of x approaches infinity. Therefore f of x is not defined. F of x is not defined at x equal to minus 1. At x equal to minus 1. In other words, f of x is not continuous at x equal to minus 1. Okay, we can say in another one format, f of x is continuous, f of x is continuous of capital R except minus 1. That is, f of x is continuous of R, continuous of capital R except minus 1. Okay. Question number 3. Find the points of discontinuity of the function f where first subdivision and fourth subdivision. First subdivision, f of x equal to 4x plus 5 if x less than or equal to 3. 4x minus 5 if x greater than 3. Okay. To check the given function is continuous or discontinuous at which point. Okay. Here x less than or equal to 3, x greater than 3 means here plot 3 in real number minus infinity plus infinity. Less than or equal to 3 means approaches left. Okay, using this function. Okay, left approaches. Right approaches means using this function. Okay, using this function. Here less than or equal to 3 means including the function. Okay, equal to 3 means including these functions. Here solution limit x approaches 3 f of x, which is equal to x approaches 3 means less than or equal to 3 means x less than or equal to 3. It means in the first one x less than 3, in the second one x equal to 3. So use the function limit x approaches 3. The function is 4x plus 5. 4x plus 5. Replace x equal to 3 into the function, that is 4 into 3 12. 12 plus 5 equal to 17. Okay, equal to 17. Therefore the f of x is exits. Okay, exits. To find left and right approaches, limit x approaches 3 minus f of x, which is equal to left approaches means using this function, that is limit x approaches 3 minus the function is 4x plus 5. Replace x equal to 3 into the function, simplified, we get the result is 17. To find right end limit x approaches 3 plus f of x, which is equal to right means using this function 4x minus 5, that is limit x approaches 3 plus the function is 4x minus 5. Here replace x equal to 3, 4 into 3 12, 12 minus 5 is 7. Okay, here left end and right end are not equal. F of x naught minus not equal to f of x naught plus. Therefore the given function is discontinuous at x equal to 3. Therefore f of x is discontinuous or not continuous. Okay, continuous at x equal to 3. Okay, at x equal to 3. Fourth subdivision, f of x equal to sin x interval 0 less than or equal to x less than or equal to pi by 4. In another one function cos x pi by 4 less than x less than pi by 2. Okay, here to refer the the given function is continuous or discontinuous. Check whether the limit is pi by 4. Check whether the limit is pi by 4. Okay, here limit x approaches pi by 4 f of x. Okay, f of x. Here less than or equal to means x in particular stage x reach to pi by 4. We take the function sin x. That is limit x approaches pi by 4 f of x is sin x. Replace x equal to pi by 4 sin pi by 4. The value of sin pi by 4 is 1 divided by root 2. Okay, 1 divided by root 2. Therefore, the given function is exits. Limit exits. Limit x approaches pi by 4 minus means approaches left hand side. From left hand side. From left hand side means using these functions. Limit x approaches pi by 4 minus the function is sin x. Replace x equal to pi by 4 in the function, that is sin of pi by 4. The value of sin pi by 4 is 1 divided by root 2. To find right end limit, limit x approaches pi by 4 plus pi by 4 plus means the function lies between pi by 4 and pi by 2 means this is the right approach using this function. F of x which is equal to limit x approaches pi by 4 plus the function is cos x. Replace x equal to pi by 4, that is cos pi by 4 which is equal to 1 divided by root 2. All the values are equal, therefore unique real number, that is therefore given function f of x is continuous at 0 to pi by 2. Okay, 0 less than or equal means using closed bracket, less than means using open bracket, that is thus at 0 comma pi by 2 in open bracket. Okay, question number 4. At the given point x0, discover whether the given function is continuous or discontinuous, citing the reason for your answer. Second subdivision, x0 equal to 3. It means the given function whether continuous or discontinuous. Identify continuous or discontinuous at x0 equal to 3. F of x equal to x squared minus 9 divided by x minus 3 if x0 equal to 3. Otherwise 5 if x equal to 3. Okay, solution. Let f of x which is equal to x squared minus 9 divided by x minus 3. Here replace x approaches 3, then f of x approaches 3 minus 3 is 3 square, 9 minus 9, 0 by 0 is indeterminate form. Okay, indeterminate form approaches to infinity. Therefore, f of x is not defined. F of x is not defined. Find at x equal to 3. X equal to 3. Suppose the given function is simplified, that is f of x which is equal to x squared minus 9, which can be written as x squared minus 3 squared divided by x minus 3. Here in the numerator, the structure a square minus b square, which can be written as a plus b into a minus b divided by x minus 3. Here the factor x minus 3 are cancelled. Therefore, the given function is f of x which is equal to x plus 3, okay, x plus 3 if x not equal to 3. In other words, 5 if x equal to 3. This is the given function, okay, this is the given function, okay. Here to find the limit, right and left limit, okay, to find right and left limit means here limit x approaches 3 f of x equal to 3 means choose a constant function, that is limit x approaches 3, the function is 5, the constant function is constant 5, then the resultant is 5. To find a left and right limit x approaches 3 minus f of x not equal to means approaches left and right limit, okay, left and right limit. Here left limit means choose a function x plus 3, limit x approaches 3 minus the function is x plus 3, replace x equal to 3 plus 3 which is equal to 6. Here limit x approaches 3 plus f of x which is equal to limit x approaches 3 plus the function is x plus 3, replace x equal to 3 into the function 3 plus 3 which is equal to 6. Here left and right limit are equal, but the given function limit exists, these value are not equal to left and right limit, okay, that is limit x approaches 3 minus f of x not equal to limit x approaches 3 f of x and limit x approaches 3 plus f of x not equal to limit x approaches 3 f of x. Therefore, this is called the removable discontinuity, okay, removable discontinuity. Therefore, the given function is discontinuous at x equal to 3. Therefore, f of x is discontinuous at x equal to 3, okay. This is called the removable discontinuity, okay. Question number 5, show that the function f of x, that is x cube minus 1 divided by x minus 1 if x not equal to 1. Otherwise, x equal to 1 means constant function is 3, is continuous on open interval of minus infinity comma plus infinity, that is continuous on at every point, that is capital R, okay, it means every point at capital R. Proof, let f of x which is equal to x cube minus 1 divided by x minus 1, okay, if x not equal to 1. Suppose x equal to 1 means the constant function is 3, x equal to 1. The given function is not defined at x equal to 1. Therefore, the given function can be rewrite into modified format, that is f of x which is equal to, this is in the form x cube minus 1 cube, that is x minus 1 into a square, that is x square plus ab plus ab, 1 into x plus b square is 1 divided by x minus 1, okay, x minus 1 if x not equal to 1. Suppose x equal to 1 means that is the constant function 3, okay, here the factor x minus 1 are cancelled, this is the given function, okay, is defined for R, okay. Here check whether the given function is continuous or discontinuous at every point, okay. Here to find limit x approaches 1, x equal to 1, f of x which is equal to, in particular stage x approaches 1 means x equal to 1, the function is 3, that is limit x approaches 1, the function is 3, that is constant function which is equal to 3. To find left end and right end limit x approaches 1 minus f of x, which is equal to limit x approaches 1 minus, choosing the function is, this is called the left approaches and right approaches. Okay, right approaches. Choosing this function x square plus x plus 1, x square plus x plus 1. Replace x equal to 1, that is 1 square is 1 plus 1 plus 1, which is equal to 3. Next, to find right end limit x approaches 1 plus f of x, which is equal to limit x approaches 1 plus, choosing the function x square plus x plus 1, x square plus x plus 1. Replace x equal to 1, that is 1 square plus 1 plus 1, which is equal to 3. Here f of x is exists, that is the function is limit exists, the left end and right end are equal, all are equal means that is unique real number, therefore f of x is continuous. F of x is continuous on minus infinity comma plus infinity. Okay, on minus infinity comma plus infinity. Okay, thank you students.